Hello and welcome. Today we're diving deep into an invisible universe, a world of microscopic life that for literally centuries held the power of life and death over all of humanity. This is the incredible story of how we finally figured it out and started to fight back. This is the story of the golden age of microbiology.
Just try to imagine a world where nobody knew what caused disease, a world where a simple infection was basically a death sentence, and where people believed that life could just, poof, spring up out of nowhere. I mean, for most of human history, that wasn't imagination. That was reality. And the key to solving all of it was all around us, but completely invisible. So let's start at the very beginning, with the first person who ever got a peek into this incredible hidden world.
So our story kicks off with that very first glimpse, because before we could even think about fighting this invisible enemy, we first had to see it. We had to know it was there. What we're talking about here is the field of microbiology, a term that was actually coined by the great French chemist Louis Pasteur. It's really the science of the small, right? The study of all the living things that exist just beyond what our eyes can see. And you know, the very first person to truly see this world wasn't some famous university-trained scientist. Nope, he was a Dutch linen merchant named Antony van Leeuwenhoek. He just had this amazing passion for grinding lenses and building his own incredibly powerful, for the time, microscopes in his spare time. So one day back in 1676, he points one of his homemade microscopes at a drop of pond water and sees something that would change everything. It was this bustling, chaotic world just teeming with tiny creatures darting all over the place. He called them animalcules, which is just a wonderful name. It means little animals. Without even realizing the full scope of it, he had become the first person to ever see bacteria and protozoa. He literally opened the door to an entirely new universe. Okay, so Leeuwenhoek proved this invisible world was real, but his discovery immediately sparked a massive question, one that would basically ignite a scientific war for the next 200 years. Where in the world do these tiny creatures actually come from? And this was the central conflict. On one side, you had this ancient belief called spontaneous generation, the idea that life could just sort of appear out of nowhere, maggots from meat or microbes from a pot of gravy. On the other side was this new emerging idea of biogenesis, that all life, no matter how tiny, has to come from other life. And scientists on both sides were trying to prove their case. You had this total back and forth. Back in the 1600s, Francesco Redi showed that if you cover meat, no maggots appear, proving they actually come from flies. But then in the 1700s, John Needham claimed he'd proven spontaneous generation because microbes grew in his heated broth. Then Lazarus Bonzani fired back by boiling his broth even longer and sealing it completely, and guess what? Nothing grew. The debate was just completely stuck. But that stalemate was finally and spectacularly broken in the mid-19th century. This breakthrough kicked off what we now call the golden age of microbiology, and it was an era totally defined by two scientific titans who would change the world forever. First up, the hero of our story, Louis Pasteur. He was absolutely determined to sell this spontaneous generation debate once and for all, and he designed an experiment that was so simple, so elegant, that it was just undeniable. Pasteur's genius was all in the design. He used these special goose-necked flasks. So he boils the broth inside to kill everything, and then he just leaves the end open to the air. Now, the S-shaped curve lets air in, but it traps any dust and microbes from that air. As long as the flask was upright, the broth stayed perfectly clear. But the second he tilted it, allowing that trapped dust to mix with the broth, bam! It just exploded with microbial life. The point was crystal clear. The microbes came from the dust. Life came from pre-existing life. And that one experiment didn't just end a 200-year-old debate. Oh no. It gave birth to the germ theory of disease, this radical idea that these invisible organisms are what actually cause sickness. And that one single insight led to pasteurization, understanding fermentation, and creating the first modern vaccines. It was a revolution. So if Pasteur was the grand theorist who saw the big picture, then Robert Koch was the master detective. He was a German physician, and his genius was in hunting down the specific germ responsible for a specific disease. Koch developed this brilliant four-step method for nailing the culprit. You can think of it like a detective's checklist. First, you find the suspect microbe in every single victim. Second, you isolate it and grow it all by itself in the lab. Third, you show that this isolated microbe makes a healthy animal sick with the same disease. And fourth,
You find that same exact suspect in the newly infected victim. Case closed. Using this, he proved which bacteria caused killers like anthrax and tuberculosis, finally giving doctors a specific enemy to fight.
So now, with the germ theory proven, the whole battlefield shifted. It wasn't about proving microbes existed anymore. Now it was all about one question. How do we fight them? And one surgeon, Lord Joseph Lister, immediately saw the connection. He thought, if germs in the air cause disease, they must be causing the horrific infections that made surgery so deadly. So in 1867, he started sterilizing his instruments and cleaning wounds with carbolic acid. The results were nothing short of miraculous. Death rates after surgery just plummeted, and operating theaters were transformed from places of almost certain death to places of healing. The fight also involved training our own bodies to become soldiers. Decades earlier, way back in 1796, Edward Jenner had noticed that milkmaids who got a mild disease called cowpox never seemed to get the deadly smallpox. He used that insight to create the first vaccine. It was Louis Pasteur who later understood the science behind why it worked, and he used that principle to develop new vaccines for anthrax and rabies. And, in a nod to Jenner's work with cows, Pasteur coined the term vaccination, from vacca, the Latin word for cow. Okay, so the final frontier in this golden age was to create actual weapons, things that could hunt down and destroy these microbes once they were already inside the human body. The pioneer here was a man named Paul Ehrlich. He dreamed of creating a magic bullet, some kind of chemical that would be deadly to a specific microbe, but totally harmless to the human patient. And in 1910, he found one, salvarsan, a compound that could cure syphilis. It was literally the birth of chemotherapy. But the greatest weapon of them all wouldn't come from a long, methodical search. No, it would be discovered by a complete and total accident. The year is 1929. A Scottish bacteriologist named Alexander Fleming gets back to his messy lab after a holiday. He sees a petri dish of bacteria he'd left out had been contaminated with mold. As he goes to throw it away, he notices something really strange. There was a clear ring all around the mold where the bacteria had been completely wiped out. That mold was producing an incredibly powerful substance he named penicillin. It was the world's first antibiotic, a true wonder drug. They managed to mass produce it just in time for World War II, and it saved an unimaginable number of lives on the battlefield. It kicked off a whole antibiotic revolution, finally giving humanity real weapons against diseases like tuberculosis that had plagued us for centuries. I mean, just think about it. In less than a century, humanity went from believing that life just sprang from mud to wielding molecular weapons against our most ancient, invisible enemies. The golden age of microbiology didn't just give us answers. It gave us control over our own survival and built the very foundation of all modern medicine. The work of Pasteur, Koch, Fleming, and so many others truly changed human history. They were giants who conquered the microbial giants of their time. But their work also opened our eyes to a universe that is always changing, always evolving. Which really leaves us with a question for today, doesn't it? What new, invisible challenges are waiting out there for us now?